excited to talk with everybody today and share a bit about what we call plan for unplanned work. So if you're familiar with PagerDuty, maybe because we wake you up in the middle of the night, our core product is incident response, incident management, and as we branch off from there, some of the things that we've learned over the years. One of the things we'll talk about is game days, which PagerDuty has been doing for the better part of like 10 years now, and incorporating some like chaos engineering and reviewing your SLOs as part of that whole process. So I am Mandi Walls. I am a DevOps advocate here at PagerDuty. If you would like to get in touch with me, I am on Twitter as LNXCHK, and my email address is mwalls@pagerduty.com. We're also hiring. Just shout out to the folks out there. If you're looking for positions, we have some things open right now, and it's a nice place to work. And happy to answer questions about that. If anyone wants to talk about that offline, you can hit me up in the SLOconf Slack as well. All right, so when we talk about incident response and we talk about what happens when things go wrong and how we want to preserve our customer experience for our customers, like getting better at all those things is kind of a double-edged sword, especially when we're talking about incidents in particular and what happens when things go wrong. Like we want to get better. And when we want to get better at stuff, that means we practice regardless of what it is. We want to have some kind of practice and some kind of place where we can work on things that makes us better. To do that with incident response though, we want to have more incidents, but no one wants to have more incidents, right? Incident response and that whole process is a muscle that we want to exercise. The workflows, all the communications patterns, and the who and the where, that doesn't just happen by magic. Like our teams set up these workflows and we work on them and we iterate on them and we practice with them. And we don't want to do that when there's like a real issue going on with our environment. We want to figure things out in advance and practice stuff and work towards, preserving the customer experience as much as we can. So on our side, we refer to incidents as unplanned work, right? They interrupt our day, they slow down all the stuff that we want to be working on. So we want to improve how we handle them so their impact is reduced and our reliability is improved. So many organizations and even individual teams use game days. Hopefully you've heard of this practice. And that's a way of building that incident response muscle and also learning about how your platforms and your components are going to react when stuff goes wrong. At PagerDuty, we refer to them as failure Fridays, or sometimes when they happen on another day, it's a failure any day. And the point really is to have this exercise to make sure that production operation systems are doing what we need them to do when we need them to do it. And that can be a number of different things going on depending on what subsystem is practicing. So there's things that we look at, like, are the metrics and observability tools giving us the right telemetry in the right way at the right time? Are the metrics and observability tools going to go to the right places? We have our escalation policies, we have these notifications. Did we set up an incident room? Is there a Zoom call? Do folks know what they're expected to do when they're expected to do it? If we need to push a fix, how fast can we do it? And who has the authority and the ability to do that kind of stuff? Is it a limited number of people? Is there like an escalation that we have to get permissions to do that? So real incidents can be super stressful, and not everyone has the temperament to be calm under that kind of stress. Like in a past life, I was a sysadmin for America Online, AOL. And like the products that we ran were the big stuff, AOL.com and a bunch of the other, what they called the channels at that time. And like, they are key components. They are in the revenue generation flow. And when things happen, like, that means there's money being lost and like executives are involved and there's all this crazy stuff going on. And like dealing with that and being in the right headspace to still think through the technical bits and also like what's going on is super stressful for folks. So we want to give our teams a place to practice with all of the other components when something goes wrong. And one of the ways we can do that is with chaos engineering. So when we go into our game days or our failure Fridays, we want to set a goal. And when we first started talking as an industry about chaos engineering and these sorts of tools, like some of the original apocryphal stories were like people just kind of going through data centers and like pulling cables out of switches. So you didn't know what was going to go down. And now maybe you could like scroll through your cloud assets and just delete one and see what happens. But like deleting something randomly, doing those kinds of things, that's it. Maybe it sounds cool. To me, it sounds super crazy, but it's not where we want to start with our reliability and our resilience improvement practice and like dealing with how certain kinds of problems and outages are going to impact our customer experience, are going to impact the SLOs that we've set for our components, and how we can think about those in a more tactical and directed way versus sort of like just going in and causing chaos. And that was the Chaos Monkey project that Netflix originally started, was, you know, part of that, like just randomly pull something apart and go just see what happens, right? So as we're looking at applying chaos engineering to this sort of like improvement of customer experience when things go wrong, stepping back and looking at how we want our systems to behave and what they're actually going to do, right? We're getting to the place where we're comparing what we think should happen and what's actually going to happen. And we're literally breaking things on purpose to learn how to get to a more resilient place. The chaos part can sound kind of scary and even like a bit irreverent, like you're not taking things seriously. So you may also find programs that are called like fault injection or something like that. So it sounds a little bit more serious and a little bit more like real engineering when folks are thinking about that. So you may see it also referred to that way for folks who are a little scared about the word chaos. Totally understand that, right? But we use it in conjunction with our Failure Fridays to validate all these assumptions we have about how our systems are going to behave when they get to meet the users. The goal of, you know, sort of combining the structure of chaos engineering and specific tests with a regular chaos practice and sort of a regular a cadence, right, to do these on a regular basis, is really helping us make sure that we're putting in front of the customer the best system we can possibly create, right, in a way that is within their tolerance for what they expect and within our tolerance for what we're able to build without, you know, sort of grinding people into the ground, right? So setting a balance between what's going out and what we're able to do. So we want to be intentional. When we put these programs together, we want to be able to say, here's what we want to get out of this. Our goals for these exercises and, you know, putting the time and resources into this is that we want to learn and improve and focus on that customer experience. That's really the whole point, to keep our customers happy and give them that best experience. So when we're planning out testing programs and failure scenarios, we want to keep the user in mind. We've gone to the trouble of building out like all of these goals. We have our SLOs that we want to deliver to, and they are built on what our customers are expecting and where we have, you know, room to fail, and how we play with that and work with our production systems within those constraints, and how we get better at it is all part of our intention here. So our testing scenario, we don't want it to just flex part of the application that the users aren't utilizing, right? Like that kind of test is like a tree falling in the woods, and it's a lot of work, right? It's a lot of work to set these kinds of things up, to put the practice together, to sort of get to the place where we know we're going to get something out of it. So we want to make sure everything that we're building towards gives us a lot of value and is going to help us focus on making the products better. Our whole process is going to help us improve reliability. So we're looking at the things that the customers like best. And maybe that's where we plan to start and how we sort of go forward from where we are. So to have a successful chaos testing and game day practice, we want to have some stuff in place first that we're already sort of thinking about and we already have in place. The first one is at least some basic monitoring and telemetry. It's absolutely fine to use game days to flex these components, give them a little bit of exercise, and make sure that you're covering the things that you think you're covering, right? You want to test the tester and make sure the alarm goes off when you've turned the thing off. So we need to start with at least enough monitoring to know that our test scenario is registered in the system, right? For example, if we're looking at how our one of our components reacts to a dependency being offline, we want to make sure that our monitors are kicking off and lets us know that, hey, this backend is offline. Basic stuff, right? Then we set up our response process. Chaos testing and game days are an excellent way to practice incident response protocols. You use an incident commander. You can assign a scribe, and you can prepare a post-incident review in the same way you would if you were having a real incident or a real outage on your system, so that you have a place where you've recorded, this is what the telemetry told us, this is what we tried, this is what it looked like after we made those sort of remediation efforts. And then we'll establish our workflows for fixing stuff. Lay the groundwork for how much experimentation do you want the team to do during the test. In a real incident, your subject matter experts might need to push code, or they might push configuration updates to remediate the issue. And you can talk about if you want to do that during the game day if you find that it's necessary. You may get to the point where your configuration doesn't allow enough heap space or something like that, and to successfully run the test that you're running. And you can talk about how far you want to push things as if it were a real remediation. But you don't have to. You can find the issues and pinpoint them and then turn the test off and be fine. Just depends on how much work you want to take on during the test and how much you just want to learn and poke at the thing and then take that back as a learning. So you can be very flexible with those. And then you want to be thinking about improvement. What happens after your game day? Too many teams spend a lot of time planning and executing these sort of failure scenarios, and then they don't get the opportunity to put the improvements back into the work stream. It never goes back into the backlog, it never gets reprioritized into the product. And the operational requirements for improving the system never get prioritized into the actual work that's going to get done during the next sprint, right? So if the reliability improvements you learn about require code changes or other changes to the platform, think about, is your product team on board with putting those back into the workflow and making sure they get prioritized and fixed? Because improving reliability, we know, is a long range process. So we want to take the time when we're working on these kinds of little projects to plan ahead and make sure our game day is going to be valuable to the team that is going to expend the resources on it. When we incorporate incident response, what we're after is helping folks replace chaos with calm. I won't go into the first step, right, that we talked about, the monitoring telemetry. Lots of folks know more about that these days than I do. A lot of my knowledge there is outdated. So we'll look at the second part a little bit, because that's where PagerDuty kind of sits, right? Game days are an excellent way of flexing incident response muscles. We don't have to mobilize a full incident response for every game day, but it's an option to keep in mind. And it's something that we kind of do on a rotating basis. So when we respond to a major incident that is having some kind of user impact, especially if it crosses team boundaries or service boundaries, right? Especially if you're in a microservices architecture and you have lots of little things going on and those things are owned by different teams, it's a good time during a game day practice to fire up a more explicit and a more involved response process just to practice, right? It's a good way to help the folks that are incident commanders practice managing an incident, because that can be kind of nerve-wracking as well. the first time you go in to manage an incident and help coordinate and make sure everybody is responding that needs to is kind of nerve-wracking. And I say that as someone who's an incident commander at PagerDuty. Like it can be also very stressful, but in a completely different way than like trying to actually figure stuff out. So it's a good time to practice with those folks too. And then, you're after improving over time, right? Your game days are a place to help your team get more comfortable with handling issues in production, especially your junior folks who are like, I don't know where stuff is. I don't know where things are deployed, or all of those, where do I find help or get information? Giving those folks a place to say, here's what your checklist is. Here's how you access the systems. Here's what you need to request from IT or whomever else to make sure that they're in there in a way that is controlled and not sort of a crazy, stressful, real outage. Absolutely helps everybody get used to then what's going to happen if something actually does go wrong in production. We're just giving folks so many ways of practicing and getting comfortable with getting back into the good user experience when we have an outage. So your game days help you verify that all of your end-to-end components are working appropriately for your incident response process. You choose your tests. Your first checkpoint is like, do we have an appropriate alert for this scenario? If I've taken a service offline with a chaos black hole test, does the system actually alert as I expect it to? Does it do something if I choose a latency test, or for disk IO, or for long running queries? If the work that I've been doing has been in the database, are we testing that stuff? When my alerts fire, what happens next? Are folks being notified? Does the team have the correct contact information in the paging system? If it's not, how are you going to get a hold of them, right? Folks get new phones all the time. We want to make sure that all that stuff gets updated before we need them in an emergency. And that might be like making sure your paging platform has a V card that is installed in everybody's contact information. I live a do not disturb life on my phone because like I get a lot of spam. So I got to make sure that our systems can ring through because they're my favorites. So they have to be enabled, right? So once everybody knows something that's up, where do they go? Are you coordinating a team chat channel? Are you on a conference call? How do team members find out that information? Do they know where to go when it's time to coordinate, right? And then finally, we're thinking about our troubleshooting. Before we're in a real failure, we want to know that everybody has access to all the dashboards they need. They can access hosts. They can get into the repositories, the configuration files, whatever else they need. They have all their permissions, all that's lined up well in advance. And using a game day is great for doing that. You have junior folks that join your team. You can have them practice restarts or scale ups or failovers during a game day that gives them that valuable experience and takes a lot of the nervousness out of, oh my gosh, am I going to break it? Sort of the first time they have to look at that stuff. So decide when you're also then going to call the experiment over. It might be time bound, right? We're going to look at this for 10 minutes of live traffic. That's totally fine. It could be more flexible. When we feel like we've learned what we wanted to learn, then we can turn it off. Scenarios can be quick, especially in systems with a lot of defensive practices already in place. So you might actually only be in there to test that the defense is still working. So this bottom image is a screenshot of our bot. So we have this little bot to help us with Failure Fridays. And we have a whole channel dedicated to any team that is using Failure Fridays. And it lets everybody else in engineering know that, hey, there's a Failure Friday exercise taking place, but it only lasts a few minutes, right? It started at 1:07 p.m. and it ran until 1:31 p.m. So for those 24 minutes, some team was doing an experiment in production with their stuff. And that was kind of enough for them to gain the knowledge that they wanted to know and not, adversely impact the users that might have been included in the live traffic that was coming into their experiment. And but it still gives everybody the information they wanted out of the practice. So we go in with some goals in mind. We might have a general goal, of course, right? Improve the reliability of our services. But if we're going to the trouble of having a game day exercise, we want to set something specific that we're going to concentrate on. So things that we might look at, right, is if we have a dependency that flakes out on a regular basis, can we like code around it? Maybe we'll test some defensive coding on those requests to see if we can improve it, or maybe we're going to code around it or use some caching. Or maybe I have a service that slows down under heavy load. So maybe we're going to test how a new database index impacts that slowdown. If users are reporting that some flow is slow, but you aren't sure why, and it's hard to catch when it's happening randomly, maybe we can get in there and take a look under live traffic conditions, try out some debugging, watch for more signals while we're actually in the live setup, right? We can also focus on larger problems like DDoS attacks, data center level failures, network trunk outages, just depending on what parts of our ecosystem we want to investigate, and maybe the places we're currently having some trouble. Maybe last quarter we burned through our entire SLO on one subsystem. So we've been working through some defensive practices. We've been shoring things up on the outside for that particular service. And we can go into our game day thinking about what happened the last time X, Y, and Z occurred in that subsystem. And here's what we're going to test to see if that's going to happen again. So there's lots of places where the long-term life of the service can come into play as we're building up our game days and our practices there. So then we're going to set our hypothesis. What do we expect to find? This is a big part of actual chaos engineering workflows, right? So if we have a system that already has some defensive measures in it, are we testing that they're going to kick in? Maybe there's going to be a failover or a scale up or something that should happen automatically. Maybe we expect the whole thing to fall over, and that is totally fine, right? We just want to prove that we have a place to start from. We definitely want to set that initial hypothesis. We have assumptions on how the systems will behave. So we want to get them down in writing. So we use them as our baseline, and then we see what actually happens, right? During our game day scenario, we want to make sure we're recording everything that goes on. We want to save our charts and our graphs, the list of commands we might have run to check out behaviors, see if there's any threads hanging in the system anywhere, any of the actions that the team took. Notating what actually happened based on what the hypothesis was, what happened in reality. Maybe our dreams came true and all of our defensive coding was amazing. Maybe the whole thing fell over in our darkest nightmares, but it's okay because it's a controlled experiment and we just put things back together. That's all right. So when we're collecting our data, we're thinking about the charts and the graphs that we first start to look at. And then sometimes we learn about, okay, that's not the full picture. We know we have this other data in another place that we weren't really thinking about immediately. And we can start to learn about our system and how it reports in. We may have black holed some dependency in the back end during our experiment, and that sort of made its way through all the other systems in interesting ways that we weren't thinking about. So it's another part of your practice for incident response and improving reliability, just to sort of get that whole view when you're running through these kinds of experiments. It really gives your team a way of looking at, especially in distributed systems, like the impacts of certain problems and outages that you might not have been thinking about. And then we record what we learned. We went to all this trouble, right? We planned, and then we told people we were going to do, and then we executed our exercise. We did all these scenarios. We worked through all these tests and looked at all these faults. And then what do we do? Then we want to share with other teams what we want to benefit from. What did we learn? We learned that this particular database index wasn't the silver bullet we thought it was going to be. So we have to go back to the drawing board. Or we found out that this particular new library that we're using for outbound requests actually improve things a lot. So maybe other folks should adopt this or upgrade to this version, or those kinds of things are totally part of what you might end up learning as you're doing development into a game day like that. So we want to put our things that we learned to good use. We want to improve the reliability and resilience of our systems. So we're going to balance non-feature operational improvements that come out of these game days back into our product cycle. The findings from your game day might generate work, right? We expect things to go into the backlog and then eventually be prioritized for production effort. Maybe we want to write better error messages in the application logs. Even something that simple is going to improve how your system behaves and how your humans will behave when there's an actual real incident in production, so you can reduce your downtime. We might need to find new defaults for some settings, things like memory allocation or garbage collection or timeouts, right? Other places we might find we really want a feature flag around this new feature that isn't behaving quite as well as we want to, and that will improve our ability to preserve customer experience when something goes wrong. Any number of things might get uncovered. You don't want to abandon them. We want to get them documented and into planning. You might actually have a post game day review, just like you would a post-mortem or post-incident review when something sort of goes wrong in real life, right? We sit down, we talk about what happened, we talk about how we learned about it, right? Here's where the monitors went off, here's where the notifications went, here's how it impacted users, and compare that to what we thought was going to happen. And then we can revise and revisit our SLOs based off of what happened, right? We might find that our SLOs aren't good enough. We might find that the current work that we're doing pushes too much uncertainty into the system, and maybe our SLOs are too aggressive. And we can talk to our product teams and say, look, our reliability is suffering with these new things that we put in, and we've tested them. Here's our data, right? Here's what we learned from our last set of game day experiments based on this work that you had us prioritize. And then we get to talk about, do we turn this thing on? Is it good enough for production based on our current levels and our current goals that we set with our teams for our SLOs? Maybe it's time to change them. Maybe your product team says, well, we really need this new feature, so maybe we'll take a bit of a hit on our performance goals and we adjust all of our SLOs based on what we learned, right? And it's kind of a mature process and a mature discussion to have when you're bringing in all of these explicit practices and things that you want to learn about the systems that you're developing, the goals that you have for their performance, and the experience that the customers are expecting, right? So we start small with a lot of these things, right? So especially in a microservices environment, each team might have their own set of services that they're working on, that they're experimenting with, and that they're setting goals and performance goals for. And then everything sort of hangs together. And a lot of that takes time, it takes effort, and it takes, your leadership team saying, yes, this is where we want to put our resources in this kind of testing and sort of live traffic experiments and all these kinds of things. So when we talk about this stuff, one of the questions that we get is that, somewhere there's someone, especially in a big team, who's like, we want to surprise everybody. We want to run these at any given time and see how folks react. And like, man, like, do you hate your employees? Do you hate your teammates? Like, come on, man. Like, that's not the place to start, right? And like, these were some of the original stories, like I mentioned earlier, that like Netflix would run. Amazon used to do this in the early days, just like go in and declare a surprise game day, right? Like, maybe when you get to a place where all of your patterns are well honed and people know exactly what's going on, right? And they've had a bit of practice. We've been talking about being sort of deliberate and explicit about what we want to know when we're running a game day, right? If we're looking to run something as a surprise, like, what's the point, right? You want to make sure you're very clear about what you're hoping to accomplish. We want to test disaster recovery at this level, and at least let folks know that this thing is potentially coming, right? And not just decide some Tuesday to pull the plug on some major component, right? It can feel more real to run these as a surprise, but yes, in real life, we don't know when incidents are going to happen. We don't know when things are going to go down. But if your team isn't consistently getting through a planned testing scenario in a controlled way with some amount of success, having a surprise day isn't going to magically make them better, right? Like, they're not ready for the real game when they're not getting through the practice. So yes, they've got stuff in production and real incidents might happen, but intentionally inflicting more stress on them isn't going to make them better, right? So when should we try this, right? When should our team talk about having a game day? When's it good to do this sort of in-depth assessment of our reliability? Honestly, any time is good, right? Like I said earlier, we have failure Fridays, we have failure any days. Someone just pulls one off at 1 o'clock on a Tuesday afternoon, but also you want to look at focusing in on when things have been going well, right? We don't want to run a production environment game day when we've already been blasting through our SLOs on a service. If your users are already unhappy with the reliability of your product, doing production testing isn't a way to make friends, right? Even if you mean well, even if what you're after is improvement and stability for a service that's been kind of unhappy, like, your users are not going to see it that way. You also don't want to blow out your error budget on testing, right? We might need that for real issues, especially if we're in a place where our service is a little bit wonky and not quite stable. So look for times when we can do shorter, focused tests when things are calm and running well, right? Maybe your time has just flipped over or something like that. Make plans in advance to run your chaos testing against new features after they've had some time to burn in. You want to have an idea of sort of that baseline performance of a new feature before we go like really taking deep pokes at it, so that we know that, yes, this wobble isn't just how the thing lives in its regular life, right? We've poked it in this way, this is how it reacted, and that is significantly different from the baseline that we observed for the past 2 weeks or whatever the case might be. So you can have regular practice game days on a regular basis. Just make sure that you're doing them when folks aren't unhappy with you anyway. There are certain times when you probably shouldn't game day. The big one for large organizations is like, don't do this when you've just had a reorg, right? Like, people laugh when I say that, but like, when you think about like, yeah, like, I've got a new team and we've got different services that I haven't seen before. The last thing you want to do is like go in there and purposely throw people to the wolves, right? Give folks time to get acclimated with their new services, with their teams, especially if you've had a lot of folks move around. And also, like, think about the time of year or your seasonality, right? Don't wait a week before your busiest season and then game day. You want to plan ahead. You know stuff is coming, right? Especially if you worked in like retail that has like very deep seasonality, and you don't want to be running your game days in the month of November at all. You should have had that stuff like solidified and ready to go September at the latest, right? Because you're going into that period of everything has to be stellar and amazing before the holiday season, right? So reconsider spending your time doing game days. Also, if your partners in the business side and in the product side aren't on board with taking input, right? And this is something that makes me very sad for engineering teams who are in this kind of situation, right? They want to run a game day, they want to do this kind of practice and make sure they're prepared end to end, but the things that they learn about the system things that they could improve upon to improve resilience or reliability, they can't get reprioritized in the backlog to get them into the production workload. Like that can be really disheartening, can be really disappointing for teams. Also kind of obliviates the point of having the game day in the first place, right? So it can still have some value that your team learns to practice, but you're not going to get the full value of taking the time to do the entire exercise and learn about the system if the improvements aren't going to be realized. So that one, I don't hate to end on a depressive note there, but like for folks in those kinds of situations, like it is kind of a bummer, right? Like you want to be in a place where you learn about all these operational things that you can be doing, but you're not able to get them back into production. So just to summarize for folks, right? We want to go in with a plan, right? We want to be intentional about the things that we want to learn about. We want to know what the end user impact of certain kinds of outages and problems is going to be. And then we want to be able to use what we learn. So for folks out there who are looking for some other stories about game days and how all these things kind of work together, there's a link here for a Shopify engineering blog post called 4 Steps for Creating Effective Game Day Tests. That's super good. That was published a few years ago. And then the second one is from the Azure blog at Microsoft. And this one is Advancing Resilience Through Chaos Engineering and Fault Injection. Just kind of giving folks a set of frameworks and places to sort of think about when they're thinking about doing these kinds of game day testing and chaos engineering and looking at their systems in a sort of 360 view instead of just waiting for things to go wrong in production. And if you'd like to learn more about putting together an incident response process, we have a document at Pagerduty at response.pagerduty.com. This is our incident response training. It's completely open sourced for the whole world there. This is the stuff that we use to train up our incident commanders, as well as the folks that we work with at our customers, and might be helpful for folks who haven't put together a process yet. And then the last one, shameless plug for our podcast. We cover all kinds of things there. It's called Page It to the Limit. And there's lots of interesting stories there about things that folks have learned. We have a couple different posts on chaos engineering with the folks at Gremlin. And yeah, hopefully that's interesting for folks. So thank you.